Recording. So the first thing we did today was this particular question. So let me get this started. And I asked everyone to find the tens term. So let me show you what the tens term would be. That would be the 6th, 7th, the 8th, the ninth, and the 10th. So I'm actually going to do part B first. So to find the 10th term, so if you, this would, again, imagine when we did visual patterns, this was a square, or this was a picture with 5 squares, and then all of a sudden increased to 15, 27, 41, 57. What would be the next one, and so forth, so forth. Well, one way you could do this is find the difference. The differences here is 10, 12, 14, 16. So the difference between this number and this next number would be 18. So I can add 57 and 18 to get 75. The next one would be plus 20, 95. Plus 22, I get 117. Plus 24, 141. And finally, to get the last one, would be plus 26, and I would get 167. So the 10th term of this sequence would be 167. But that's nice. But what if I asked you for the 89th term, or the, I don't know, 124th term, or something like that, or really down the line? Let's try to find a function out of this. Okay. So imagine. Not imagine, but remember when we were doing visual patterns and imagine something that had 5, I don't know, 5 circles, and then it grew to 15, grew to 27, grew to 41, grew to 57. So imagine that, but obviously without visual. So let's see how we do this. So the first thing I want you to do is take the first difference. If you take the first difference, there's a difference of 10, 12, 14, 16. Now, obviously, because the differences are not the same, this tells me that I need to take a second difference. And by taking the second difference, I can tell you that this is a quadratic function. Now, the function here is it's a quadratic function, which is going to be n squared, right? So now you got to decide if it's going to be 1n squared, 2n squared, 3n squared, 4n squared, 5n squared, or whatever it is. So one of the ways we do this is to have this difference right now. So, and half of 2 is 1. So in this case, it would be 1x squared. But let's say the difference was 4. If you took half of 4, that'd be 2, and you would write a 2 as your coefficient. If your differences was 6, half of 6 would be 3, and that would be a 3n squared sequence. So now that we established that it's just an n squared sequence, let's write it out. So the n squared sequence, and then again, substitute with 1. 1 squared would be 1. 2 squared would be 4. 3 squared would be 9. 4 squared is 16, and then 25, and so forth and so forth. Now I'm going to erase this for a second. Okay. So now I'm going to take away the quadratic sequence out of this first sequence that we have. So I'm going to subtract. When I subtract 5 minus 1, I get 4. 15 minus 4, I get 11. 27 minus 9, I get 16. No, I get 18. 41 minus 26, I get 25. And 57 minus 25, I get 32. So I'm left with this sequence. So I know that so far, this sequence here is made up of n squared, but I'm not done yet. Now, once I subtract it, I have this other sequence in here. I'm going to take the difference, and it's 7, 7, 7, 7. So it's a linear sequence, and it's going by 7. So let me take this away. Now, that particular sequence is a 7n sequence, right? Because it's going to go by 7, 7, 14, 21, 28, 35, etc. So it's a 7n sequence because it goes by 7. So the first sequence in a 7n sequence would be, well, if I substitute here with 1, I would get 7 times 1, which I get 7. If I substitute with 2, I would get 14, right? So the 7n sequence, 7, 14, 21, 28, 35, etc. So now I know two things, that there's a quadratic sequences, and there's also a linear sequence in here, and that's going to be called 7n. Now, it's the next thing you have to do is ask yourself, the 7 sequence here, once you have established a 7n sequence, what does it take to go from 7 to 4? Well, you would subtract 3. From 14 to 11, you would subtract 3. 21 to 18, you would subtract 3. And 28 to 35, you subtract 3. And 35 to 32, you subtract 6. So it's a 7n sequence, but not exactly, but it's a 7n sequence minus 3. That's the function of the sequence. Now, if you wanted to double check, remember, this is the first term, the second term, the third, the fourth, and the fifth. Let's substitute n with 1, the first term. I should get 5, right? Because that's the first number in my sequence. So if I substitute, I get 1 squared plus 7 times 1 minus 3. 1 squared is just 1. 7 times 1 is 7 minus 3. 1 plus 7 is 8 minus 3 is 5. So again, so therefore, it's correct. You can substitute again with another number just to double check, but eventually you'll find out that this is the sequence. So if I wanted to find, I don't know, let's call it 30th term, okay, the 30th term of this sequence, right down the line, this 30th term, I would substitute it with 30, and I get 30 squared plus 7 times 30 minus 3. 30 squared is 900. 7 times 30 is 210 minus 3. This would give me 1,110 minus 3, and I get 1,107. So the 30th terms in this sequence would be 1,107. So if I went down the line and looked for the 30th term, I would get that. So this is what the function is. So let's see if we can do that again. So pause. I'm not going to find the 10th term. You can do that by yourself, but I want to find the function here. So let's take the first difference. It's a 6. What is this? 8, 10, 12. Again, their difference. So that tells me that this is going to be a quadratic sequence. And if I take the second difference, I get 2, 2, and 2. Now, I know it's a quadratic sequence, so it's going to be an n square sequence. And it's going to be a 1n square sequence, right? Because if I have 2, half of 2 is 1, so I put 1 over there. Well, I don't even need to write it. But let's write out what a n square sequence would be. Well, 1 squared is 1, 4, 9, 16, 25, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So now, what we have to do is remove this quadratic sequence from this and see what we have left over. So 3 minus 1 is 2, 9 minus 4 is 5, 17 minus 8 is 8, 27 minus 16 is 11, 39 minus 25 is 14. Okay, so I have another sequence in here, and if I do this, it's going to be 3, 3, 3. So that tells me it's a linear sequence. So besides a quadratic sequence inside this suite, there's a quadratic sequence. So I know it's n squared for sure. Now it's going by 3, so this is a 3n sequence, right? A sequence that goes by 3. So let me write 3n. And let me write the 3n sequence. 3n sequence would be, starts with 3, and it goes to 6, 9, 12, and 15. So I know it's n squared plus 3n. And now you ask yourself, how does a 3 get to 2? It would be minus 1. How did the 6 get to 5? It would be minus 1. How did 9 get to 8? Minus 1. How did 12 get to 11? Minus 1, and vice versa. So it is a 3n sequence that's happening, but not exactly a 3n sequence. A 3n sequence minus 1. This sequence wise here, it's going up by 3, but 3 and then subtract 1, right? So again, let's substitute. Let's take the second term. The second term gives you 9. So let's see if I actually get 9. So I would get 2 squared plus 3 times 2 minus 1. That's 4. 3 times 2 is 6 minus 1. 10 minus 1, and I get 9, which is exactly what the second term should be. So I can use this to find any term of the sequence that I would like. So that's one of the things we did. The other thing we did was, and I'm going to go straight to this. Now, no, not to this one, yeah. So one way of, and I think I have Desmo up, so let me just, I want to show you something. 2x plus y equals negative 1, 3x minus y equals negative 9. So hopefully I do have Desmo up, and I do. So I'm going to put these two equations in here. So this is an awesome tool. Plus y equals negative 1. So if I were to graph this, and you will tomorrow, this is the line that you would get. This is the line 2x plus y equals negative 1. Now, why is this not working? The second equation is 3x minus y equals negative 9. Now notice that these two lines meet at this point, and in this point is called negative 2 and 3. So that particular point, if I substitute the value of negative 2 and 3 in here for x and in here for y, I would have the left side equal the right side. So again, let me get the answer, negative 2 and 3. So that's the point of intersection between that red line and the blue line, negative 2 and 3. So going back to this, I'm looking, my answer is going to be negative 2, and I'm going to write it in here in the corner. 3. Let me do this backwards. So let me substitute this value, that's the x value, this is the y value, in the first equation. So I would get 2 times negative 2 plus y, which is 3, equals negative 1. 2 times negative 2 is negative 4 plus 3 equals negative 1, and you can see that that value makes this equation true. Let me take the second equation, is 3 times negative 2 minus 3 equals negative 9. 3 times negative 2 is negative 6, minus 3 equals negative 9, and I get that negative 9 equals negative 9. So you can see that this value, this one point, right, that one point made this equation true and made that equation true. Now, it's much easier when you just graph it and you find the answer, especially on a graphing tool like Desmos. But since we're not there yet, we're going to have to find this manually. So one way, the different way to find that today is by elimination. So what we're going to do is we're going to add these two equations. So in this case, let me explain why we're adding. If I add these two equations, I get rid of that plus y and the minus y because they're opposites, right? Plus y and negative 9 should give me 0. And by doing that, and I'll show you, 2x plus 3x, first of all, is 5x. Plus y minus y gives me 0. So literally, this disappears. Equals, and negative 1 plus negative 9 gives me negative 10. This is an equation with a single variable, which we can solve and find the value for. Divide by 5, and I get that x equals negative 2. So now that I have x equals negative 2, I can pick either this equation or this equation. Let's pick the top one, 2x plus y equals negative 1. Substitute, because x equals negative 2, so I'm going to replace x with negative 2 plus y equals negative 1. 2 times negative 2 is negative 4 plus y equals negative 1. I'm going to add 4 to this side and add 4 to that side. These two will cross out, and y equals negative 1 plus 4, negative 3. Not negative 3, sorry, positive 3. And so my answer is negative 2, negative 3. What does that answer represent? This answer represents, and I'm going to go back to the graph, this value right here. Negative 2 and 3 up, the point where these two lines meet. So the point where those two lines meet now makes this equation true, makes that equation true if I were to substitute. So negative 2 and 3, and I did that earlier in the beginning of the question. So that's what we're looking for, the point of intersection. Let's do this one. And this one, if I look at these two equations, I can clearly tell that if I add, these two x's will be eliminated. So x plus negative x is just 0, so I don't have to write anything. Y positive plus y positive is 2y. And 1 plus 5 is 6. Divide both sides by 2, and y equals 3. Great. y equals 3, I take any of this, either of these equations. I'll substitute. So x plus y equals 1, x plus 3 equals 1. I'm going to subtract 3 from each side. And this disappears, and x equals -2. So the point of intersection between these two lines would be -2 and 3. So I'm going to graph that. Let me just write it down. X plus y equals 1, negative x plus y equals 5. So again, let me go back to Desmos. So let me graph that first equation, which is x plus y equals 1. That's what the line will look like. Okay, and then I'm going to enter the second one, which is negative x plus, negative x plus y equals 5. So where do these two lines meet? And you can tell the lines meet right here, and it says that's -2 and 3. Let's see if that's what we have. Yep, -2 and 3. So manually we're finding the point of intersection between these two lines, and that's our task today. But here comes a problem. If I leave these two equations as they are and I decide to add, let's see what happens. There's a 1 here. I'm just going to put a 1 there. So 1x minus 2x is negative x. Negative 2y plus 4y is negative 2y. Sorry, positive 2y. And negative 2 plus 4 is just 2. Now, you notice that in this case, hey, by adding, I still have two variables, and I can't solve when there are two variables, right? So I didn't get what I wanted to, which was by adding, I wanted to eliminate one, either dx or dy. So I need to make some changes. Here's what I'm going to do. I'm going to multiply the top equation by 2. So I'm going to multiply this 2 by this 2 by that, and this 2 by that. So let me do that. 2 times x is 2x. 2 times negative 2y is negative 4y equals, and 2 times negative 2 at the end is negative 4. Let me write the second equation. Negative 2x plus 4y equals 4. In this case, note, and the reason I multiplied by 2 is so that I can get a 2 over here, so that when I add, I have two opposites, right? Because they will become 0. This is a special case here. If I add these two, that's 0. If I add these two, negative 4y, that's also a 0. And guess what? Negative 4 plus 4 is 0. So in this case, I have 0 equals 0. So this is a special case here, where there is an infinite number of solutions. The reason being that no matter what point I put in here, you'll see what I mean by when I graph it, they will satisfy both lines. So let me just write this down. Negative 2, negative 2x plus 4y equals 4. Let me go back to Desmos for a second, and let me input these two. So x plus 2y equals negative 2. And my second one is negative 2x. And notice where it is. That's the first one is the green one. Negative 2x plus 4y equals 4. Oh, did I do something wrong? Negative x. Oh, it's not negative x. It's plus x here. Sorry. Oh, did I copy this wrong? Sorry. X minus 2y equals negative 2. Negative 2x plus 4y equals 4. So let me go back. X plus 2y. X minus 2y. My God. Minus 2y equals negative 2. And then the bottom one, let me graph it again so you start. So that's my first one. Negative 2x plus 4y equals 4. And notice that in this case, you have one line on top of each other. So that means that any point that I pick on this line, okay, any point that I pick on this line will satisfy both of these equations because they're on top of each other. And that means that there's infinite number of solutions as long as they're both on this line. So if I take this point right here, which is, I don't know, negative 899, let me just, negative 9.07 and negative 3.535, and I substitute that into this equation and this equation, it would make those two equations true. If I pick this point right here, 1.04 and 1.52, and substitute in there, so any point as long as it's on the line will make these two equations true. So let's move on to this. Now, this is a little bit different. Let's say I want to get rid of the x. Right? What would I have to multiply 3 by? What do I have to multiply 3 by so that it becomes 4? I can't. There's nothing multiplied by 3 to give me 4, so I can get rid of the 4. Right? And likewise, there's nothing I can multiply the 2 to become 3, so I can get rid of the y's. In this case, you're going to have to multiply both equations by something so that they both have the same value. So let's take the y's, for example. The LCM between 2 and 3 is 6. So I'm going to multiply this first equation by 3. And if I do that, I get 9x plus 6y equals 8. I multiply the second equation by 2. I get 2 times 4x is 8x. 2 times negative 3y is minus 6y. And 2 times negative 12 equals negative 24. Can you see why I multiply one by 3 and the other one by 2? By doing that, I got the equations each to have a 6 coefficient in front of the y. One positive, one negative. Now I can add these two. 9x plus 8x is 17x. 6y minus 6y is just 0, so this will cross each other out, right? So this will disappear, which is exactly what I wanted. And 8 minus 24 is going to be, sorry, I forgot one thing here. Now I know why it's wrong. This is going to be 3 times this 9, 6, 3 times 8 is 24. Okay, so and 24 minus 24 is 0. That's okay to have a 0. Continuing, I divide this by 17 and this by 17. This will become 1 and x equals 0. So x equals 0, I have to find y, so I can pick, and you have 4 different equations that you can pick. Pick the easiest one, and I'm just going to pick this one. I take 3x plus 2y equals 8. I'm going to substitute here. Instead of the x, I write 0 plus 2y equals 8. This is going to disappear because 3 times 0 is 0. So I'm now left with 2y equals 8. Divide this by 2, divide this by 2, and I get that y equals 4. So the point of intersection is 0 and 4. Because we're still not graphing yet. Let me see what that means. So that means that if I took 0 and 4 and substitute in the first equation, 3 times 0 plus 2 times 4 equals 8. That should make the left and the right equal each other. 3 times 0 is just 0. 2 times 4 is 8. And guess what? It equals the 8 on the other side. If I took the second equation, 4 times 0 minus 3 times 4, is that equal to negative 12? 4 times 0 is 0 again. That goes out. Negative 3 times 4 is negative 12. And guess what? So 0 and 4, these two values, when substituted either here or here, make that inequality true. And again, if you were to graph this, and you can, by yourself, go to decimal and just input this graph, this equation, and this equation, you'll see that they would both intersect at 0 and 4. Okay. I'll do one more, or a couple more. So in this equation, again, if I were to add them as they are right here, that would be 8x, 2y minus 5y is negative 3y, and 8 plus 11 is 19. I got nothing accomplished by just adding them. So I need to make some changes. So I either need to get rid of the x's or get rid of the y's. You choose, it doesn't really matter. So I'm going to choose the y's because one is already positive and the other one's already negative. So I don't really have to worry about signs here. Okay, so LCM of 2 and 5 is 10. Okay, so I want to make the 2y become a 10, and I want to make the 5 one become a 10. So in order to do that, I have to multiply that 2 by 5. And this line, I'm going to multiply by 2. And remember, you have to multiply every term inside. So let's do the top one. 5x times x, 5 times 5x is 25x. 5 times 2 is 10y. And 5 times 8 is 40. So there. Bottom one, 2 times 3 is 6x. 2 times negative 5y is negative 10y. And 2 times 11 is 22. So now, notice that if I add, the y's are going to get eliminated, which is what I want. 25x plus 6x is 31x. These two are adios. 40 plus 22 is 62. Divide both sides by 31. And I get that x equals 2, which is a beauty. Now I get to go here and pick one of these equations. Let me just pick the first one, 5x plus 2y equals 8. And in that equation, I'm going to substitute. I'm going to replace the x with 2, so I'm going to get 5 times 2 plus 2y equals 8. 5 times 2 is 10, plus 2y equals 8. I'm going to subtract 10 from this side, 10 from this side, and I'm going to get that 2y equals negative 2. Divide both sides by 2, and y is going to be negative 1. So I found the x coordinate and the y coordinate, and my answer is going to be 2, negative 1. And if I, again, take a second, it's nice, go to Desmos, input this, and you'll see that wherever the intersection, that point where both lines meet, the coordinate point is 2, negative 1. Okay, so also, you should take the time 2 and negative 1, and just, I'm going to check. So I'm going to replace the x and the y with 2 and negative 1, and we get 5 times 2 plus 2 times negative 1. I'm going to put that in parentheses, equals 8. 5 times 2 is 10. Positive and negative is a negative. 2 times 1 is 2 equals 8. And you can see that it worked for this equation. Let me do the second equation. It would be 3 times 2 minus 5 times 1. That should give you 11. It's negative 1, by the way. 3 times 2 is 6. Negative 5 and negative 1 is positive 5. That equals 11. And you get that 6 plus 5 is 11. So you see this point makes this equation and this equation true. So that point intersection, which we're looking for, makes those two equations true. Well, that's pretty much it if you missed. I am going to put in a homework assignment online, and that's it.